Okay, this video is for teaching how to simplify square roots or simplify radicals, that's specifically square root radicals, as an algebra skill. We're going to use as this first strategy the idea of working with perfect squares. So here's a list of perfect squares from 1 through 15, and the list would continue on, 16 squared, etc. A perfect square is a number multiplied by itself. So any number can be multiplied by itself and give you a perfect square. For example, 20 times 20 is 400, and so 400 would be considered a perfect square. The reason we want perfect squares is because of this bottom line. The square root of a perfect square is always an integer and never a decimal. When we simplify square roots, we want to simplify with numbers that are not decimals. So working with the perfect squares gives us a way to do that. For example, the square root of 16 says what number times itself is the number 16. So that result would be 4, because 4 times 4 is equal to 16. The square root of 100 is equal to the number 10, because 10 times 10 gives you the perfect square 100. So when we simplify square roots, one of the strategies is to work with perfect squares. Here's a couple examples we're going to do, and I did put some steps as well that you can use. First step is to break apart numbers into pairs of factors. So for the square root of 8, there's really only one thing I can think of besides 8 and 1, and that's the square root of 4 and the square root of 2. 4 times 2 is 8. For 200, you have some different options. You could do something like the square root of 25 times the square root of, what would that be, 8? 8 times 25 gives you 200. Or you could do the square root of 50 times the square root of 4 would give you 200. There's different factors you can come up with. You can use your calculator to divide 200 by different numbers to see what works and what doesn't work. As long as it gives you a number that's not a decimal, that would be okay. So 200 divided by 3 gives you a decimal, and so we wouldn't use 3 as one of my factors. And then let's see, another one that would be nice would be maybe just 2 and 100. And then one more, 20 and 10. Notice I have the square roots with all those. So break apart numbers into pairs of factors. Those are all different factors of 200. The second tip is that we want to specifically find perfect squares that are one of my factors. So this bottom example with the 20 and the 10 in pink is not going to be a good one to work with for this strategy because there's no perfect squares. Here's the perfect squares again. 20 and 10 are not listed in blue at the top of the page. So I'm not going to use this one because there are no perfect squares. The other three options all do have perfect squares. 25 is a perfect square for the top, 4 is a perfect square for the middle, and the bottom one is 2 and square root of 100. So the 100 is a perfect square. And you can simplify the perfect square factors. So if I go back to my problem on the left, the square root of 8 becomes square root of 4 times square root of 2. The square root of 4 simplifies to just the number 2. And so that's my final answer, 2 times the square root of 2, because the square root of 4 is equal to the number 2, because 2 times 2 is 4. So that square root of 4 can simplify to the number 2. I want to go to a new slide and start over with 200. Square root of 200 can be broken down different ways. When it can be broken down different ways, we have the 25 and the 8, the 50 and the 4, the 2 and the 100. The strategy we talked about in class is to look for the largest perfect square. So out of those, 25, 4, and 100, the largest perfect square is 100. So if I break this down to 2 times 100, both underneath the radical, the square root of 100 is the number 10. So I have square root of 2 times 10, which the standard way to write that is to put the integer first, so 10 root 2. So the main strategy that we talked about in class was to use perfect squares as a way to find and simplify square roots. In the next video, I'm going to show what happens if you don't use the largest perfect square or just another strategy to work with.